I got 7:31. Is that right? Yeah, 7:31. Everyone please rise for the Pledge of Allegiance. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. All right, welcome to the December meeting of the Gloucester County Amateur Radio Club. Can somebody get me a head count in the room and on Zoom? 13 on Zoom, and however many's in the room. Okay. Do we have any guests in the house? Any guests? Any guests on Zoom? No guests. Any new members? New members in attendance? New members on Zoom? Oh, here's a new member? No? No new members. Okay. None. Well, that's not good. Can I get a message? A motion. Yeah, see, I can't even talk. I'm done with this job. Can I get a motion to approve the minutes as published? Seconded. All in favor? Opposed? Okay, passed. Treasurer's report.
Okay. Treasurer's report year to date for budgeted items. A total income of $10,346 and total expenses of $7,738, which leaves us with $2,608. The only big bill that hasn't been paid is the mowing. I should be getting the mowing bill, which will be about $1,000 to $1,200. So it looks like we're still, we've done well as far as the budget. We're not in the hole as far as the budget goes. And total money in all bank accounts is $47,094. That includes $25,000 in grant money, which is separate, so to speak, and $4,000 that is still left for the rebuild fund. Any questions? All right. Your motion to approve the report? Second. All in favor? Okay, treasurer's report. Jim, did you want to do new business? Okay. What do you want me to go into Clubhouse? All right, we'll move into committee reports. Clubhouse. Clubhouse is in pretty good shape. Well, actually, now that it has a nice brand new shiny roof, it's in extremely good shape. Thanks to Frank for setting this up with a very good company that we were able to do a nice roof, not just any old cheap roof, but a very high quality roof for less than the $3,000 that we budgeted. And anybody who's done a roof lately knows that that's an extremely low price. They had to put quite a bit of new plywood along the edges of the roof. But we should be, we were joking that the clubhouse will rot away, but the roof will still be sitting on the ground. That's how good the roof is. So since this is the end of the year, I wanted to just kind of mention that how much has been accomplished at the clubhouse. We really got a lot of stuff done, mostly in the second half of the year. A lot of hours of labor, a lot of expertise from from volunteers, which is, of course, how most things get done in clubs. Otherwise, we would not be able to afford all the work that has been done. Obviously, the HF station getting back on the air with a refurbished tower and a nice shiny new beam was glad to get that accomplished. The VHF room is coming along nicely. A lot of work, which some of it is not obvious, like the wiring. Of course, the room was stripped down to the studs. All new AC wiring and network wiring was put in. All new insulation and closing up leaks, air leaks, and all new paneling, and also a new ceiling, thanks to Frank Romeo for most of that. You go in the room now and you can just tell that there's no air leaks because it just feels warm even with no heater turned on. So it'll certainly save us money not having to spend as much on heating and air conditioning when the summer comes. We also, of course, got the shed painted and the front stairs repaired and painted. So anybody who helped out in any way, whether just for an hour a day or more, it's certainly greatly appreciated. And we have still quite a lot of work ahead of us for next year, but I think we did extremely well this year. And that's it for Clubhouse.
Okay, thanks, Al. Next committee is club nets. Any reports on any club nets?
Tony, this is Steve.
Steve?
For the 2-meter nets, the Tuesday and the Thursday for the past 5 weeks, we had 57 total check-ins on both nets. So we're averaging a little over 11 people checking in each week. So we're doing pretty good with that.
Okay, Steve, that sounds like you're holding your numbers. That's good. No 10-meter net. Is Jim is Jim in Zoom? Okay. All right. I don't know if he had a report. Probably no net. Okay. DX and contests. We had the 160, ARRL 160, and the conditions were terrible. Yeah, but they were really bad this time. And my noise level was low, so I thought I was going to work a lot of DX. I had 3 countries. 3. So I've worked more than that when my noise level was 20/9. But it is what it is. The SFI is about 150 this week, so I'm hoping the 10-meter contest is going to be great. We'll see what happens. I'll probably be busy all weekend during the daylight hours, but I'll take a listen when I can. I'll keep the spotting clusters on. I'll see if I see anything exotic coming in. It should be a good time to hear some DX on 10 meters. And other DX, haven't been doing too much, so I don't really know what's on there. There's a couple of DXpeditions active for the past month, but I didn't get a chance to get on and work them. I've been too busy. So looking forward to the 10-meter contest. Hopefully we hear a few club members on there. And I think that's about the last big one for the year. There might be some others that I don't know about, but that's the last ARRL one anyway. So that wraps up the DX and contest committee. Repeaters is next. Do we have any report on the repeaters? No report. Okay. All right. Education committee, Chris.
Okay, not a whole lot going on right now because we're between sessions educationally. I did not run the session that was scheduled to start November 14th for 3 reasons. One is the holidays are on us. 2 is I had some conflicts with instructor availability. And 3 was we had relatively low interest this time around. So rather than run it for just a couple students, I figured I'd hold those people till February, and they're willing to do that. Currently, our DigiNet program is working on WinLink, and we'll do the second session as well. Sorry about that. The next topic in the DigiNet is going to be FT8, and Steve Farney, W2SCF, is working on that program right now. I believe that Jim and Sheldon are also working on a concurrent program to be presented to the general membership. So they should coincide nicely, hopefully. One other thing I did want to mention is that I have been scheduled for some eye surgery that's going to occur. The first surgery is going to occur the same week that we start up the next session of the classes. It will not affect the class schedule. The classes will go on as scheduled. So don't anybody worry about that. It is going to happen. Okay. And one final note, a gentleman who just walked in the door is one of our newest members, Randy Testa. He is with us tonight for the first time, sitting in the back row back there.
Hi, Randy. Okay. Someone want to double check me on the head count. I thought I had 28, but maybe I'm off by 1. Okay. The next committee normally in this slot we haven't been doing is the Hamfest, but I'm going to bring it up now because it's in this slot, and the 4-H has requested a $300 deposit and made it sound like if we didn't do it right now, we would lose the date. So we had to go ahead and do it. It's budgeted for next year, but because we have to pay it now, I need an approval from the membership to pay it. So can I get a motion to pay $300 to the 4-H to hold our date? Motion made. Seconded. Opposed? Okay. Thank you. And that ensures that we will have our September date locked in September 10th this year. Okay. And that's all I have for the Hamfest, September 10th. Okay. Next committee up is the Tech Committee.
Okay, so as Al mentioned, we got a new clubhouse roof. Let me get out of your way here, guys. This is a shot of the roof being installed. Can we turn the side lights of the other presenters on so we can get the whole screen? So you can see the guys working up there. And let me see if I can get this to advance. Well, so I'll do that. Whoops. So this is what it looked like as of Sunday. This is with it done. We tried to get them to put W2MMD and the tiles on the roof so that anyone flying over in an airplane would know where our clubhouse was. They were not able to do that for the fee that we were quoted. Right. Chris is going to go up there and spray paint it on, right? So these are the guys that did this. As Al said, and as Frank has said before, they did a great job for a great price. And we told them that we would, mention their names to every club member. We would put it in crosstalk. And, if you're looking for a roof, get a hold of these guys and, tell them that you were referred from the radio club, because they really came out and they did a terrific job for us. And also we had a lot of volunteers out there to help, specifically these guys. The clubhouse was open. This was a Friday morning. The clubhouse was pretty well staffed. There were a whole bunch of guys that came out and did all sorts of stuff that had to get done. And thanks to volunteers who come out and do anything. Specifically, one of the things you've got to do after you get a roof done is you got to roll this rolling magnet around to get all of the nails up. And so the first rolling magnet was run by the contractor, and then a bunch of our guys ran it around again, and then Earl ran it around the third time. And this is what he ended up with, the third pass of the rolling magnet. So anybody who parks at the clubhouse can thank Earl for not having nails in their tires. That's true. Yeah, if it's not there, you can blame Earl for it. Oh, and while I had the drone up on Sunday, I took a shot of the new beam, so you can see what it looks like. You guys on Zoom can probably see it a little better, but that's what it looks like from about 10 or 15 feet above the new HF antenna. So the HF room was remodeled, as Al said. This is what was happening. I think this was a shot on Saturday. You can see John, K2QA, Frank, N3PUU, Earl is down there, and Ron is standing up. There's a green line right there. You can see that Ron is not getting measured for short pants there. That green line is the 3D laser that Frank used to basically make sure that the plywood that's being put up is put up straight and accurately all the way around the room. And then this is cutting the copper stripping that's going to go behind the networking cabinet, which I'll show you a picture of in just a minute. So that they basically had to run the copper all the way up from that strip down below, all the way up to where behind the networking cabinet is. This is what that part of the room looks like now. You can see the plywood is run all the way around. You can see the copper stripping is run around. You can see where the outlets are. I've got a close-up shot of the outlets a little bit later. And then this is the networking cabinet. The big networking cabinet is back up there. You can see it's all grounded. And in the corner, you can see there where the antennas for the VHF station come out. In particular, take a look at the cables on this thing. I think, what is there, like 40 cables running through there, John? Anybody who thinks that the network at the clubhouse is simple needs to take a look at that diagram right there. That's the dark blue cable. The light blue cables are fiber optic that are running from the HF room and then from the closet. Is that where the other one's coming? And then from the closet. And that's because in case there was a nearby lightning hit and you get inductance, if you've got a metal cable up there, you can get current running in it. Ron, am I right about that? Okay, so Ron basically forced them to put the fiber optic cables in so that there won't be any inductance coming in there. So we've got some really complicated networking going on in that clubhouse. And then this is the wall where the VHF satellite, and there's going to be another workstation there. And you can't see it from here, although the Zoom guys can see it. There's 4 cables coming out of each of those ports there. Okay, so there is a lot of network infrastructure in this room. Changing topics, the Rowan rocket guys came back. So remember last year, I talked about the fact that the guys from Rowan who were working on building a rocket for one of their school projects, they came over in May and the rocket project was due in June. So we kind of figured they didn't have a lot of opportunity here. Well, I got an email in October from Nicholas, who, by the way, got his technician class license so he'd have a licensed radio amateur who could run the station in the rocket. That's basically why he got his tick. But he came over a couple of weeks ago and talked to some of the guys. I wasn't there. And then he came over last Saturday and he brought over the radio that's going to be in the rocket. There's actually a controller that's made by a company that's run by B-Dale Garby, who was one of the packet radio pioneers. I remember his name back from the 80s in packet radio. And he makes these rocket controllers. So it's got a transmitter, it's got a receiver on 434 megahertz, and it's got things like control to shoot the ejection charge to pop the top of the rocket open and launch the parachutes. And I'll show you a close-up of that on the next slide. But he brought this thing over and he had an antenna that didn't work very well. They tried this thing out. The range was not really good. So we took him into the HF room and Chris stuck that antenna on a nano VNA and found it was resonant around 300 megahertz. So it wasn't going to work very well on 440. So we started clipping off 1/4-inch segments of it, using the nano VNA. We got that sucker right on to 434 megahertz. And then Nick and I jumped in my car and we started driving around, and Chris was listening on the disc cone with an SDR radio in the clubhouse to try and see how far we could we could hear them. Unfortunately, there was an adjacent signal right on the same frequency. So that didn't work out real well. We need to do a little bit more testing on it. This is what the setup looks like. You can see this is not the way it's going to fly in the rocket. This is just a mock-up so they could have the all the stuff held together. So this is the main controller. This is the secondary controller. And there's your ground plane antenna. This thing's mounted on an SMA connector here. And that's what we stuck on the VNA, and we got it set up. And these wires are these are not solid. These can be bent down because this thing's going to go in the nose cone of the rocket. Okay, so they're actually going to be bent down like a disc cone is. So more to come. They were really interested in continuing to work with us. I was hoping that Nicholas would actually come tonight because we invited him to come. But this may be the introduction of us to the Double E department over at Rowan, and any radio club, and particularly the foundation, has a education mandate. So if we can develop that relationship going forward, I think it will be really a great thing for us. The problem we've got is that Nick is a senior. We need to get some sophomores and juniors in there so we don't lose them at the end of this. This is the upcoming general membership meetings. Ron, you want to go through this real quick?
Starting next month, somebody who's not quite familiar with us, I think, is a new guy, Tony Starr. There he is. Okay. Tony is going to talk to us about 5-band DXCC, which should be pretty good. In the February time period, we've got a duo, Jim Wright and Sheldon Parker, and they're going to go and show us remote operations from their Flex radios, which they both have one, for phone CW sideband and FT8. And then in March, John was just talking about the Mr. Cruz from Rowan. We've been able to twist his arm a little bit, and he's going to come and present a program to us. So that should be very interesting. And he's threatening to bring the rocket with him. So we may even have a little bit of show and tell. So that should be very nice. And then where is he? Ah, there you are. Did I do you justice? Fantastic. Thank you. April, Mr. Bob Heil, Dr. Bob Heil will give us a little bit of a talk. And I've asked him to slant it toward the new generals. So he really is going to, I guess, I don't think we could ever have him without talking about the audio side. So he's certainly going to start out with how we hear and how that is influenced by the spectrum that we listen to. And then he will branch out into some antennas and then phasing. And I tried to pin him down on phasing a little bit. He says, yeah, it's going to go from audio to RF. So it's going to be all over the place. So I'm not sure how much of a control I have over it, but I'll do my best to try to keep him focused on the new ham process. So that's as far as we've been able to get so far.
Yeah, Ron has really been laying out the sessions. So I think we'll have great sessions all year. I'm going to go back 2 slides just so Nicholas can see what we were talking about before we walked in. Chris and Nick, that's what we were showing right before you walked in the door. So we did talk through your project already. At the break, guys, if you're interested, he's right over there. Go ask him about the rocket project. And then we showed a picture of your device, and we talked about cutting down the antennas. So we've already had a discussion about that. And then this is Ron just gave me that slide he just showed you right before the session. So, but it didn't have the Tech Saturday stuff on it. So I wanted to just go quickly through Tech Saturday. The program this evening is to talk about 3D printing. I've got a little session to talk about 3D printing for ham radio. And then on Saturday, which is Tech Saturday, we're going to do an overview of CAD programs. We were going to bring in a 3D printer and print something, but that's like watching paint dry if you've ever, printed something. So I'm going to talk about Fusion. Frank is going to talk about SketchUp, and then Carl's going to talk about AutoCAD. So we're going to be talking about the different types of CAD programs that are out there, both for amateurs and professionals. And then the 10-meter contest is this weekend, and the station will be open and ready to go. Tony told me a little while ago that he worked 115 countries in a weekend during the DX contest on 10 meters, just on 10 meters. So if you want to come over and run the station, it'll be there. All the stuff's working, the new tower's up, and you'll have an opportunity for that. And then Ron talked about the session in the general membership session in January. Tech Saturday there is Chris is going to go through a session on the oscilloscope that's in the repair station, because that's a lot more complicated than a lot of stuff I've worked with. And then the RIDI contest starts at 2:00 that Saturday. I don't know who's interested in RIDI. There's guys that are still interested in vinyl records and taking pictures with film cameras. So your RIDI goes back to the beginning of ham radio, and we'll have that set up. We've got FL Digi running on the computer there, and if you want to come over and run the RIDI contest, you're welcome to do that. Digital training nets, Chris mentioned them. The first and third Mondays, I actually hadn't been doing that, and I went back and watched the YouTube videos of a couple of them a couple of days ago, and I was really missing the bet. They're doing some really interesting stuff there. So if you're at all interested in digital, make sure you're on them. The sessions are actually run on Zoom. They're not actually run on a net, so that you can share a screen and look at what's actually going on. Chris has the links for all of the meetings coming up already on the W2MMD website, so you can go look up what the Zoom's connections there. And as he said, Mike Thompson is going to be doing the second of the 2 VARA sessions on the 19th, and I'm going to do a short session on RIDI on the 12th next week. So great opportunity if you're interested in stuff. This is something that I'd like to try to do a little more of next year. And this is kind of a potential group project that actually John and Frank came up with when we were talking about stuff. So this is what the weather station looks like now. And if you can see it, there's a Raspberry Pi up there, and there's a whole bunch of sensors and all sorts of stuff connected to it. And it's all on one Raspberry Pi, and it's pulling about 9 amperes, and it's all together in one piece. And it doesn't really work well in the way that the new VHF station is going to be worked out. And what they suggested, which I think is a really great idea, is instead of having one big computer that's got all the sensors on it, take something like an ESP32, which you can get 3 for $15, and dedicate it to a particular sensor. So take an ESP32 and put it on a temperature sensor. Take another one, put it on a air quality sensor. Take another one, put it on a motion sensor. And then have these things communicate through MQTT, which is a really easy protocol, into a Raspberry Pi that's collecting all this stuff. And that's already set up. We already have a Raspberry Pi that's acting as our MQTT transponder, and dump the stuff into a database. And the thing I like about this is that you could take one of these and build one, and everybody could build a different one. And then we just bring them down to the clubhouse, and yours is picking up daylight, and his is picking up CO2, and his is picking up motion, and his is picking up the temperature in the HF room, and his is picking up the temperature in the closet and stuff like that. And it's a project that a lot of people could collaborate on and each do a little piece of it. So kick it around. If you're interested, let me know. I haven't really started on it yet, but I just think it would be fun to have a collaborative project that a whole bunch of different guys can work on, and you each have your own piece of it, and yet it all comes together. So think about it, and we'll talk about it further, but I just kind of wanted to put it out there and see what people would be interested in. A little bit of business from the foundation. I've talked about Amazon Smile in the past, which is a project that Amazon has where you can sign up and with a particular public charity, of which the foundation is one. And Amazon will contribute 0.5% of your purchases to that foundation. We got about 6 of us that are already signed up for that, and we've already got about $100. Okay. If everybody else signed up, we'd end up with more. So that's $100 that can go towards paying an electric bill or buying some propane or, you know, some other stuff for the clubhouse. So the way you do it is listed up there. But if you just Google, how do I sign up for Amazon Smile? You can do that. And then when you're going to the Amazon website, you just go to smile.amazon.com instead of amazon.com. And whatever you buy, you know, the club gets 0.5% of it. So it's really turning into some money. And, you know, if just more people did it, Gloucester County Amateur Radio Foundation. Okay. That's what you'd have to, that's what you have to type in. Okay. Do I have anything else? No. So that's it. Questions? Okay. Thanks.
Thank you, John. I have amended my notes that our guest in the house from none is now one, Nick, KC3 RFB. And I'm happy that we're working with the engineering school at Rowan University. So the next committee, I don't know if it's a committee, but the Fox Hunt Committee is not really a committee. Do we have Fox Hunt's news? Let me bring you the microphone.
Hey, so this weekend we have the fox hunt. It would be good practice for rocket hunting. So which we did radius on, 5 miles out or 3 miles out? All right. So I have some low pass filters that I built. I'm not going to put them in. So if we stay tuned at the end of the fox hunt, we will test out my custom design low pass filter as well. So we'll do a main fox hunt and then a little mini with my low pass filter that's going to suppress the third harmonic, so we can get some close in hunting practice that we seem to be needing.
Very good. Okay. Another good one coming up. All right. The next committee is Constitution. Let me get Ron here.
Did you put it up? There we go. Oh, you're all excited about this. I can tell. One of the board members happened to be paying attention more so than some of the others, and noticed that when you ask folks to submit an application, one of the requirements for the application is that you have to have a sponsor and that you have to have the sponsor's signature. You know, doing that over a web type of interface, which is where probably majority of the applications come from, it doesn't work very well. So the suggestion from the board is that we eliminate the requirement for a sponsor signature. Okay, and that requires the rewrite of section 1 of the membership material. So sponsor completely. Correct. Did I not say that? I should have said that. Okay, let's look at, if you would, the next slide. This is the original article that is currently in force in the Constitution. So an applicant for membership in the club shall present to the membership chairman a properly completed application. Okay, that so far is pretty good. Okay, now in the red it continues, which must have a signature of a sponsor who is a member in good standing of the club. That's where the rub comes in. Continuing then, the application for membership shall be acted upon by the membership committee and be presented to the board of directors for approval or disapproval. There's not really going to be any change there. And then upon approval or disapproval by the board of directors, the membership committee shall notify the applicant of the board's decision, either by mail or at the next regularly scheduled general membership meeting. Seems a little awkward and doesn't work with today's scheme of being of communicating in electronic mode. So the proposed words are as follows now. Okay, this is the amendment. Okay. The applicant for membership in the club shall present a membership chairperson a completed membership application form. Same words as before. Okay, the applicant for membership shall act, the application for membership shall be acted upon by the membership committee and presented to the board of directors for approval or disapproval. Same words. Okay. The membership committee shall notify the applicant of the board's decision. Okay. So basically, we've eliminated the requirement for a signature of a sponsor, in fact, for sponsor completely, and then given the membership committee free rein as far as how they communicate back to the member as far as his acceptance or non-acceptance. Okay, that's the issue. Now, on the last slide, the rules for approval is I've got to read it to you twice. Okay, that's the first one. I'll do it again next month. Okay. It will appear in Crosstalk. I've already got that article ready to be submitted. And then we will go through a vote probably next month. So think about it. If there are problems or changes or things like that that you'd like to have, please communicate. Yeah, we can have discussion now. Go ahead, Chuck.
Can we go back to the, I guess it was the previous slide.
On the proposed change.
Yeah, the question I have is an applicant for membership shall
you got it.
Okay, shall present to the club, to the membership chairperson. Is submitting an application on the web equivalent to submitting it to the membership chairperson? It seems rather specific in the wording.
You see, I hear you. The membership chairperson, they're the original words that were there. And yeah, we're making changes. Jeff.
That doesn't say that. That says the applicant has to present the application to the membership chair.
I can't hear you, Chris. I'm sorry.
Yeah, he had that on that first.
Say again. Yes, and I'm working on that right now in parallel.
To the membership chairman. He may not even know who that is. The application goes to go over the web. Change the wording to accommodate that.
I can do that. Yeah. Anybody have any objection or other comments on that, on Chuck's suggestion? Yes, sir. Yeah, go ahead.
I can.
All right.
I'll make a motion then that the proposed article for membership be changed to I won't say exactly how it should be changed, but to allow an applicant to submit a membership application to the club instead of to the membership chairman.
So shall submit.
To, yes, exactly. Submit the application either, and it can either be via the web or in person at the Hamfest. There's, you know,
You shall submit a completed membership application.
right.
Okay. Other changes, discussion? It really didn't serve any function. You know, the question for those listening is, why did we get rid of the sponsor? It really didn't serve any function. I've been on the board for, I don't know, 7 years now or something like that. And yes, we see it come in, but it's just there. It doesn't do us any good. There's no vetting or anything like that. So it's sort of a hangover of a prior time. Okay. Thank you, sir.
Thanks, Ron. Okay. Health and welfare, any health and welfare reports? Anybody sick or?
Yeah, Tony, this is Steve. I've got one. One of our members had cancer surgery today. It's Rolf, KD2 VQG. And we need to keep, he was at the University of Penn, and we need to keep him in our thoughts.
Okay, I got that from Steve and from Chris. Rolf, KD2 VQG, right?
Correct.
Okay, recovering from surgery for cancer. Okay, no other health and welfare reports. Okay, that concludes the election. The committees. Yeah, that concludes the committees, with the exception of the election committee. And you ask, what is the election committee, Jim? Yeah, we can do that under new business. I have you penciled in already. Okay. Yeah, so this election committee doesn't exist, or didn't until tonight. I found that the Constitution, somebody pointed out to me that the Constitution doesn't allow the president to direct the secretary to cast a single ballot in the case of an uncontested election. It must be convened by the election committee, and they have the authority to direct the secretary. Right. It was in Roberts. So on the spot, I have convened an election committee of 3 rank and file members. John, K2ZA, the chairman of the committee, and his worthy committee members, Gary N2WHV and Mario W3CGS. How's that for quick on the spot? So these guys, when I call for the election, which is coming up under old business, they will direct the secretary to cast a ballot, since I don't have the authority to do so. So that's the election committee report. Old business. We have I need a motion to reimburse Riley Hollingsworth for his expenses for his visit and nice program. We made the offer to him that we would pay for his transportation and lodging expenses, and he submitted them to us, and it's somewhere over $400. So for that type of expenditure, I need a motion to pay it. Do you have a total, Al, or is that about it? Somewhere around $400. Okay, so could I have a motion to reimburse him? Motion made, seconded, all in favor? Aye, opposed? Thank you. Okay, any other old business?
Don't forget, I guess everybody saw the field day results in QST. And of course, in the crosstalk, that we got first place in our 7 Alpha division. K2AA did eke us out in total point. They were in the 8 Alpha. But we did really well again this year.
Very good. Okay. No more old business. I have Jim under new business. Let me see. And I'm going to do the election thing last, just because that's the last thing. So Jim, you're up. Let me give you the microphone.
So in accordance, so what this is about is the annual trustees audit of the books of the treasurer. So in accordance with Section 11 of the Gloucester County Amateur Radio Club's bylaws, the trustees conduct an annual audit to be reported on in time for the December general membership meeting, which this is. So what this covers is the period spanning up until the end of November, where the treasurer provides copies of all the Quicken books, receipts for all payments for the years, all the supporting material that is needed in order to do an audit. We've been working on this. We have about a 20-page audit report, try and do it pretty detailed. We haven't completed the whole report, but I wanted to give a summary. We'll have that completed report for the Board of Directors meeting, which meets in 2 weeks. But the summary is basically a good summary, which is the audit was completed with only minor discrepancies. There will be several recommendations for the Board of Directors, as noted in a recommendation section. But all of the club treasure, and I'll give you in writing, Carl, so you don't have to try and take it as I'm speaking here. But the summary is this: the club treasurer's main roles of recording the day-to-day transactions, reporting at the club meetings, collecting the membership fees, maintaining the banking, paying the bills, ensuring the financial deadlines are met, making of filings, keeping accurate records, being able to be available to answer the questions from the club membership. All these things are considered to have been fulfilled with satisfactory bookkeeping and reporting through the period. So the conclusion is that the audit did not uncover any significant problems, and that the books of the treasurer through November should be accepted as presented. So thank you, Al, for doing such a good job as our treasurer.
Thank you. Any questions? Okay. All right. The last thing on my agenda is the election. And I am going to read to you the offices and candidates, and then I'm going to turn the whole thing over to the head of the election committee, and he will direct the secretary to cast a ballot, since there's no contested positions. So for president, we have John, WB2MNF. For vice president, Ron, NR2B. For treasurer, Al, KB2AYU. Recording secretary, Carl, W2KBF. Corresponding secretary, Frank, N3PUU. 2 directors, Chris, AD2CS, and Jim, N2GXJ. And finally, a trustee, John, K2QA. And those are the offices and the candidates. And now I'm going to turn this over to John Zaruba, and he will make a motion that the secretary cast a ballot.
Whereas we have an uncontested ballot, I make a motion that the recording secretary cast a unanimous ballot for the incoming slate. Second? All in favor? Opposed?
Make sure you guys sign it. All right. Thank you. Congratulations to all the new officers. Applause. It's been a pleasure serving as your president for the past 2 years. It went by really fast, and I have already volunteered to serve on about 12 committees, so I'll still be involved. So thanks for making it a pleasure and for making it easy, because it really was. And that's it. Our program tonight is an introduction to 3D printing. Let's have a brief intermission, get some refreshments. Chuck has something. Okay. Thank you. Thank you. It was my pleasure. I'll do it again someday, but not anytime soon.
On Zoom, Mr. President.
Okay. Refreshments. Oh, and 50/50. Buy your 50/50 tickets right up front here.
Okay, so when we were looking for sessions to do for Wednesday night meetings, Frank and I came up with the idea of doing something on 3D printing. And Phil had some, Phil requested it, Frank reminds me, and there's some other guys that were interested in it. This is one of those sessions where I'm really hoping that everybody out here doesn't know more than I do. Okay, but what I'm going to show you is what I know how to do and what I've done some of and what some of the other guys have done. And then we'll see where we can go from there. So what I want to talk about is number one, how a 3D printer works, some of the stuff you can make, finding some pre-designed stuff. You know, you don't have to build everything yourself. Sometimes somebody else has already built something. And then I'm going to show you a real basic session on how I build out a really simple work object for the satellite station. So this is what my printer looks like. All right, I have a Prusa printer, pretty similar to whatever the other printers are. You can see there's this table here, and this moves in and out. There's a print head here. Sorry, you guys on Zoom won't see my laser, but the print head can move sideways. Okay, there's a band here that moves it sideways, and then there are two knurled rods here that move it up and down. Okay, so it can basically move in 3 dimensions, and then there's two spools of filament here, one here that's black and the other one here that's gray, and the gray one is connected up there, and then there's a control knob down here. Because I've experienced runaways, like I'll show you a little later. This is a little Wise camera that's aimed down at the bed, and this is a little gooseneck lamp that's aimed out at the bed, and that will let me watch what's printing from someplace other than sitting in front of the printer, which I have to do in many cases, including the case of the example that I'm going to show you tonight. So this is how these things work. Basically, you've got the bed that moves in and out. You've got the head that moves sideways. And then, like I showed you, there's these knurled rods here that will move it up and down. And that's where you're getting your 3-dimensional movement. And this little thing injects down filament and starts building up layers of it like this. So there's basically, here's your roll, and here's these little wheels that are in the head, and that goes down and it squeezes it right through this, this print head here. And then it starts laying layer after layer after layer of whatever you're printing with on top of the previous layer. Obviously, there has to be a previous layer. Okay. And as the bed moves, it will decide where that stuff goes. So really basically, that's how the printer works. I'm going to mention printer filaments just because I had to put it in someplace. And I am not an expert on this stuff, but there are different types of filaments you can print with. I'm used to printing with stuff called PLA, which is really general purpose stuff. It's pretty easy to work with, but I've been told by Frank and John Zaruba and the guys that are really expert at this, this is not heat resistant, not strong. It works and it warps in sunlight, and you really can't use it for anything that needs to be strong or outdoor. Oh, John says it smells like cotton candy. So I've never tried to get high on my 3D printer, but maybe that'll work. There's stuff called PETG, which I have worked with. It's a little tougher and harder to print with. There's stuff that I called TPE, which I'd never seen. Got this off of the web, that is apparently a little bit more pliable. I guess it's kind of like the silicon glue and stuff like that. Carl's nodding his head, so maybe I'm right about that. And then there's ABS, which is similar to toy plastic. It's a lot stronger. The problem with that, at least for me, is that the fumes are toxic. And I've got mine in an open room, so I can't do that if I want to remain on the surface for a little bit. Mark. I have not, but others have said yes. The question was, have I had trouble with PLA going bad? And the answer seems to be yes. Okay, but you can dry it out. Okay. All right. So what can you make with it? I've got a lot of examples of stuff here just because people say, well, what can you do with one of these things? So I've done some of these, and some of these are pictures that other people have given me. Some are a little specious, so you might have to be, on your toes to figure out whether they really are 3D printed or not. So this is a power pole mount. You can see there's a bunch of little power pole connectors in there. I needed a way to wire them together. And so I found this model online that just let me put a bunch of power poles together and run a wire through them. And it held them all together. It did exactly what I needed. This is a mount for the satellite station relays. We needed to mount the relays on the wall, and there's no real good way to do it. So you can see basically they hang from the mount, and we screwed it onto the wall, and I designed that little thing, and it works great. This is similar. This is a diplexer for the satellite station, and they're made to sit on a desk, except we didn't want it sitting on the desk. We wanted it hanging on the wall. And so it's just a little pocket that the thing sits in, and I designed it so that the indentations right here and right here lined up with the diplexer, and it just sits there and hangs on the wall and holds the diplexer up. This is a housing for the weather station. I think John made this, did you not? John Zaruba printed this. Okay, and that's outside the clubhouse. It's probably made out of ABS, I guess. John's nodding, so it is. And that covers up the temperature sensor for the weather station, but lets it measure what the temperature is. This is a case for the satellite antenna switch. Frank did this, and I wish I could show you all the stuff that's inside, because there's a lot of 3D printed pieces inside this thing. But basically, you can see the buttons to control the relays and the LCD panel on it. The interesting thing about this is that this was hanging on the wall in the satellite station, but in the new design of the satellite station, we don't want anything hanging on the wall. So all we need to do is take that and redesign the case, make it so it sits on a desktop, and all the guts of what are inside, which is an Arduino and relays and some stuff like that, they all stay the same. We just redesign a case, and you got a completely different product for a completely different situation. Okay, another advantage of the 3D printing. This is a box for the other net receiver. In there is just a circuit board. I think John Zaruba printed this one also. Okay, just a nice case that allowed us to mount it on the wall. This is a set of downdraft SU carburetors for a 1963 Ferrari 250P. Mike K2 MRP says that he printed these things, but I'm kind of doubtful of that. Then this is an enclosure for the clubhouse temperature sensor. We have temperature sensors in each of the rooms of the clubhouse, so we can monitor what the temperature is. Inside this thing is a Raspberry Pi Zero. Mounted on the top of it is a BMT 280 sensor, and we just needed something to keep them safe and contained. So I just printed a little box that contained it, and put some holes in the top so that the temperature sensor could get touch the air, and it works really well. This is that thing is an oxygen analyzer for a scuba tank. If any of you guys are divers, you'll know what that is. And I wanted to be able to put it inside this little Pelican box, and I didn't want it to rattle around. So I just designed a 3D printed fixture that's the size of the Pelican box. So there's the box, and I just drew basically two oblong things and connected them together and printed up, and it fits inside the case and keeps the oxygen sensor from banging around. This is a piece of work. This is the ASL rotator for the satellite station, and Frank made this, and John also made one. This is a design from the Satnogs people, but it's all printed individually. And this is what we used on field day for the satellite station. It works beautifully. Oh, and Frank brought it over. It's brought it over. So take a look at some of that stuff. I see the temperature sensor cover there too. So this is a thing of beauty, and it shows you what you can do with 3D printing. Okay. This is the 3000 pipe Wanamaker pipe organ in Philadelphia. Frank said that he printed this. I think it took most of March in 2018 to print that stuff up, but it works really well, and it sounds really great. If you've ever heard the Wanamaker organ in Philadelphia, you probably didn't know that part of it was 3D printed in Frank's shop. This is a rack for the Skunkworks Pi and SDR project that was in the clubhouse until we had to take it down for the VHF room. Each of these things is a pull out. This is a pull tab, and this whole thing slides out. So this is basically rack mounted Raspberry Pi, and this is a shelf here for the the SDR radio. We found the plan for this online, and then Frank modified it to work for this purpose. And then I took it one step further. In this case, this is a Pi 4 where I had I wanted to add a USB drive on here, and I wanted to mount it as part of the Raspberry Pi. So you got your Pi here, and I just designed this little rectangle with holes for the tie wraps, and then holes that match the holes in the Pi, and bolted it on. And that means that we can connect an SDR in here. We can connect a memory module and only use one slot rather than two slots like we did before. Again, it's really simple, but it's just a piece that needed to be done. And I designed it once, and I printed about 8 of them because we have about 8 of them, and that's what we needed. This is a box for a satellite controller. This is an Arduino Mega with a Grove hat on it, and there's an ADC in here to read the potentiometer in the rotator, and there's a bunch of relays underneath it, and the LCD panel here. And we basically designed this thing with the bottom and the sides and the hole here, and mounts for the Arduino. So it basically is a custom designed case for a custom designed piece of equipment. And then finally, this is a sample that came. This design came with my printer. So all I did was press a button to print it. And if you look at the intricacy of that thing, it's unbelievable. It took 13 hours to print, but it's just incredibly detailed, and it shows you what you could do with a 3D printer. So there's some examples of what you can do with this stuff. You know, we've got a lot of 3D printed stuff down at the clubhouse. So if you want to print something, you don't have to start from scratch. In a lot of cases, you can just go out there and Google stuff, and you'll find pre-designed designs for a lot of stuff. So here I just went and Googled amateur radio 3D print, and you can see, you know, antenna mounts, another antenna mount, HT holder, and a microphone holder, and some kind of a rack, and there's a center insulator, and all sorts of stuff. And if you go look at one of them, you'll see, for example, this is a antenna feed point. So this is the page you would go to if you clicked on that, and it shows you a blow up of it, and it shows you down here. It'll tell you that there's an STL file that you can download. I'll show you what an STL file is in a minute. And you basically can download this thing and print it. So if that's exactly what you want, you don't have to do any design work at all. Okay, you just grab the thing, bring it down, print it, and you've got it. This is another example. This is a mount for a 5 gigahertz helical. So you would take this thing and you'd wind the wire around it. Okay, again, it's already designed. All you got to do is bring it down. Here I went on this website, and what I typed in up there that you can't see is power pole. What do you got for power poles? And it's got all of these different things just for power poles. So if you're looking to mount a power pole someplace, this is where you could find the designs for it. And in fact, I found this one. I think if you buy these things, this is a chassis mount for power poles. I think this thing goes for like $25, you know, and you can print it for 50 cents. So, you know, sometimes it's worth actually going out there and looking for it. The filament for these things is really, really cheap. Almost nothing costs more than $1. Okay, so you can afford to make mistakes, which is good for if you're somebody like me and you make a lot of them. So that's what you can do if you can find something that's already designed. What happens if you need to make something yourself? Okay. So here's an example of one of the things that we made. This is a mount for a software-defined radio, for an SDR Play, that we actually use down at the clubhouse. So basically what we wanted to do is take that thing and screw it onto the bottom of the satellite table so it'd be out of the way, but we could get to it if we needed it. So it's just a simple trough. It's got 5 elements to it. You can see I made a mistake in the design here where I joined 2 edges together that don't meet. And I pointed out the 5 rectangles. If you look at it end on, you can see there's 5 rectangles here. One here, one there, one there, one there, and one there. Keep that in mind because that's how you start building the thing. All right, we're basically starting from those 5 rectangles. So what do you got to do when you want to do this? Well, you got to start measuring. So I have this digital caliper that I used, and that's what the SDR play looks like. And you got to measure the depth of it, and you had to measure the height of it. And I had to remember to include the feet, otherwise the thing will be a little bit too small, and I'll have to go start all over again. And then measure the width of it. So you need to know what those dimensions are, obviously. In this case, it didn't matter too much because we were going to have a little bit of slop anyway, so we could slide it into that easily. But some of the stuff you got to be dead on, which is why you really need the caliper like that. And then this is a video of actually starting the design. So what you'll see happening here is the first thing you do is, this is a three-dimensional design. You can kind of see the three-dimensional picture up here. I'll pick which of the three axes I want to build this thing on. I want to build it on the bottom, so I'll click on that. And then if you remember those rectangles, I'm going to draw each one of those rectangles. So I'm going to go up here, and I'm going to grab a tool here that draws a rectangle, and I'm going to drag it down, and I'm going to drop it onto the workplace here. And you don't have to size the rectangle perfectly, because the dimensions of the rectangle will show up as you're trying to draw it. So what I'm doing is I'm just kind of drawing a rectangle, then I can tab to the length and type in the length in millimeters, and then tab to the height and type in the height in millimeters, and it'll automatically size the thing for me. So I don't have to be exact the way I draw it. I just kind of have to get it on there. And there was something else I was going to tell you about that, but I can't think of what that is. John. Right. No, for those of you on Zoom, what John said is working in millimeters is a heck of a lot easier than working in inches, which is what I've always done. So the thing I wanted to mention is each of these is one of those little rectangles. So the length of it is going to be dependent on the size of whether it's the top or the bottom of the SDR case. The width is always going to be 2 millimeters, because that's how thick I want the plastic to be. All right, so just that's the part that I want to remember. So here we go. Oh, this is Fusion 360. I'll tell you about it in a second. Okay, so here we're drawing the first rectangle, and I'm typing it in the dimension, and I'm typing in that dimension. And then I'm going to go grab the next rectangle. There's probably a better way to do this, but this is the way I did it. Grab that, and I think I did the dimensions backwards on this the first time. Yep, I did it backwards. Then I'm going to go grab the third one. If you hear anything coming out of my computer, I did this while the 3D printer was printing. So the noise in the background is 3D printer noise. There's that rectangle. It's the Prusa Original Mark III, I think, or something like that. So that's actually the mouse motions you would go through to put the first 3 rectangles down, and then the other 2 you would put on the top. I didn't do that because I was afraid I was going to screw them up, and then I'd have to start all over again in the video. So that's that part of it. And then when you get done, that's what the whole design would look like in 2 dimensions. All right. And it's got all the measurements on there. It'll automatically measure them, but I also measure them myself. And that's the 2-dimensional design of it. So how do you get 3 dimensions out of it? You literally tell the thing to take the 2-dimensional object and pull it out. And that creates 2 dimensions out of 3 dimensions. So basically, the 2-dimensional part of it is down here. And if you could read this, I'm sorry you can't. It basically says pull. You see this little arrow here? You select all of these pieces and you say pull. And it'll say how high. And right in here, I set 100 millimeters. So it's basically creating that 3-dimensional object out of that 2-dimensional design. All right. That's how that part works. Okay. So that's that piece. I need the holes because I'm going to screw that thing into the bottom of the table. So what I did there is I went back to each of these surfaces, and, up in the top where I'd grabbed that square, I grabbed a circle and I dragged 4 of them down here. I don't have to place them carefully because one of the other things I can do is I can tell it where to place an object relative to another object. So in each of these cases, I said, I want this 15 millimeters from the edge. I want this 15 millimeters from this edge. I wanted 15 millimeters from this edge, 15 millimeters from this edge, so on and so on. So I didn't have to drop them in the right place. I could drop them anywhere. And then I just said, make it 15 millimeters away. And that's how I got it to be symmetric. Because if I had to do it by eye, there's no way that would come out anywhere close to that. Okay. And then I take those circles and I pull them through. Okay. If you push, you're creating material. If I pull it, it takes it away. So I basically said, take each of those circles and pull it to the opposite side. And what I could have done is I said, I want you to take the circle on one side of the edge and pull it 2 millimeters to the other side of the edge. But there's another option where I can say, take it from one side of the edge and pull it to the other side of the edge, wherever the other side of that edge happens to be. And that's what I did. So basically I click on one side, I say through, and it'll say to what? And I literally turn that object around and I clicked on the other side. And what that does is these are 2 millimeters thick. If I made it 3 millimeters thick, then the hole would be 3 millimeters. Whereas if I said, just make the hole 2 millimeters, it'd still be 2 millimeters. It'll be 1 millimeter short. So you can do stuff like that, which is really, really cool. Then I added the fillets, which are kind of the little rounded edges on. I didn't know what a fillet was, so I did 3D printing. There's a function in here that basically allowed me to select the top and then put a 2 millimeter fillet on it. And that gave me an edge like this edge here. Okay. Which makes a nice rounded edge. Okay. So you've got stuff like that. And that's probably where I stopped because that's all I really needed. And it's all I really, really know how to do. So the next thing that I would do is I would tell it to go 3D print that, and I'll show you that step in a minute. But I kind of took a step in the meantime in that I had seen in Windows that there's a program called 3D Paint and a program called 3D Print. And I wondered whether that had anything to do with this. So the file that you create in a 3D printer designer is an STL file. It's a 3D image. And I said, I wonder if I just try and open this thing in the 3D Paint program in Windows, I wonder if it does anything. Well, son of a gun, it did. It opens it like that, okay? And I can rotate it around in that program. So I've got a little video. Tony, I keep standing in front of you. I'm sorry. I actually fooled around with it, and I'll show you what happens. Here, I just grab the mouse. And in the 3D print program in Windows, you can do that, which is really pretty cool. You're manipulating a 3D object in one of the Windows programs. I probably could have painted something on it if I'd wanted to, although the 3D printer doesn't know anything about paint. It doesn't know any painting. All it knows how to do is print. But I thought that was kind of an interesting observation for me to see how this 3D printing stuff, goes into Windows. So the next thing you got to do is you got to print it. And there's a function on File, 3D Print, and you select the object that you want, and it dumps it into a program called a slicer. So this thing you can see, this is the default. So it laid the thing on its back on the bed of the slicer. This is where you would bring in an STL file. If you downloaded something, if you didn't design it, you bring it into this program here. Okay, you haven't designed it, you've just downloaded it off the internet. Now, you can't print this thing this way. Why can't you print it this way? Well, you see the little flanges hanging out here. What's underneath them? Air. Can you hang a 3D line on that? No. So you can't print it this way. Now, there is a way. There's a function in the slicer called supports where it would actually put plastic under there and would allow you to do that, but it's going to waste a whole bunch of plastic, and you're going to have to take it out, and it's going to take a lot longer. So what I did is I just rotated it, and I rotated it 90 degrees, and I stood it up on the ends, and now it's got plastic underneath all of the pieces. So that will print okay. The problem you've got with that is that you don't have a lot of surface connected to the bed. Okay, all you've got is those little edges that are connected to the bed of the printer. And as the head moves back and forth, if that comes unadhesed to the bed, the thing's going to start flopping around and you're done. Okay, and in fact, in the example I'm going to show you, that's exactly what happened. So you'll get to see that happen. Okay, and the right way to do that would have been to put a little bit more surface down here. Maybe I put a back on it or a half a back on it or something like that. So I'm laying down more surface so it can stick to the bed better, and it's less likely to get knocked off when the head is going back and forth like that. Okay. So this is a time lapse of probably an hour's worth of printing. You know, I set this stuff off and I went and started watching reruns of Yellowstone for a while. And because I have that little Wise camera hanging over my 3D printer, I was able to take my phone every 15 minutes or so and check and see how the printing was going. And you'll see it's a good thing that I did that. So here's what happens. This is why we did not bring a 3D printer to the clubhouse so you could watch this print. This is about an hour. You know, I mean, Beth was only getting into her second fight, you know, in Yellowstone when this thing started going awry. There you go. All right, and you see, I caught it after a couple of minutes, so that was it. So that's basically the intro. I'll just show you a couple of other things that I had a double of a time with. Getting the bed level is a pain in the neck in these things. This is a print that it gives you. It's basically a standard print that you can use to print out what it should look like. Each of these things should be nice and flat and even. And they weren't. And I'm sitting there for, you know, probably a week with feeler gauges between the bed and the head, trying to adjust things. Even though it self-adjusts, it doesn't self-adjust all that well. And finally, I got to that, which is exactly what it's supposed to look like. And that let me print that castle that I showed you on about the 20th slide that was really, really detailed. And that's how it works. So on Saturday, we're not going to show you 3D printer because it would be, again, watching, you know, paint dry. But I'm going to go through Fusion 360. I'll bring over my computer and actually show you how you design some of this stuff up to the limited amount that I actually know how to do. And then Frank's going to show you SketchUp. Now, Frank did the designs for the VHF room in SketchUp, and they're really nice and detailed and powerful. So that's really interesting. If you're doing large scale projects, apparently that's the program to work with. And then Carl, who works with AutoCAD for a living, is going to show you what real professionals can do with one of these programs. So if you come out on Saturday morning, we're going to start at 9 like we usually do. And we'll have some interesting stuff to look at. Also remember the 10-meter contest is on Saturday. The HF room will be open. And so there can be a lot to do over at the clubhouse on Saturday. Any questions or comments?
Yeah, okay, I got a question.
Oh, yeah. Go ahead.
Oh, me?
Yeah, Charlie.
Okay. What is the height restrictions on that?
My printer is 2.5, 3 feet high with the filament rolls on it, something like that. Or are you talking about how big is a printer, or how big can you make something?
No, how big of a object can you print? How tall?
Oh, probably about a foot high, probably a foot square, a foot cubed, I think.
Nice.
So if you wanted to make something that was bigger than that, you'd have to make it in pieces and put it together.
Oh, that would be all right, because I was going to try to make a coil, but it said it needed to be 1/8 inch on center, and I couldn't wind that by myself.
Yeah, you could certainly do something. Well, an eighth of an inch is pretty small. So, any other questions? Yeah, Tony. Frank, you want to answer? I don't think so. Frank's answer was depending on the plastic, it's easy or hard. Carl?
What's your weather, the material that you print with?
Hang on just a second. We have a question in the room. Go ahead, Carl.
Temperature restrictions.
I'm sorry. Okay. Whoever's on Zoom, go ahead with your question.
The material for outdoor use, what would be your extreme temperature range for and that UV resistance?
John or Frank, you want to answer that?
There's probably no less than 20 to 30 on the market, varying friendliness to printing.
So there are several different options for printing. One of them, Frank says, would go up to about 200 degrees.
Okay, that's cool.
Carl. It's not. It doesn't stick that hard. Prussia actually gave me a little paint scraper thing that I can use to get under there. No, it doesn't stick that much. It's usually the other way around, and you'll see what I just got.
Did you have to dial in the extruder and the bed temperature?
Yes, I have to tell it what stuff I'm printing with, and it knows then the temperature.
Okay, so you're using the standard, like the standard temperatures for PLA?
Yes.
Okay.
Yeah. John, go ahead. Okay, for Zoom people, just to summarize that, John's printer has more temperature capability than mine does, and you can change the temperature of the bed to make it stick when you need to, and then release it when you need to. Sheldon, you had a question? John or Frank? A question is, if you printed multiple items and wanted to glue them together, what kind of glue? Can you glue them?
Other plastics like PLA do not respond to any solvents that you want to screw around with. So you're left with things like TA glues or epoxy.
So for you on Zoom, it depends on the plastic. Some of the stuff you can glue and some of the stuff you can't. It might have, but then I'd have to glue it fairly exactly. I think the right answer would have been to put a lip on the bottom of it, so that there would be, a couple of square inches on the bed. And then Frank says a slicer will do that if I knew how to do it, but I don't. So, anybody else?
Does anybody have any experience with printing on glass?
John does. Let me give him the mic.
Yeah, what do you want to know about printing on glass?
Well, as far as do you feel that it's more successful or less successful? Like I have glass on mine, and I've learned that I had to increase the bed temperature just so the heat could propagate through the glass. So I
Okay.
didn't know if anybody had any tips or anything.
Well, like my printer has a glass bed on it. I have to kick the temperatures up a little bit, but it's not that big a deal. But the glass is really good, especially if you're printing a flexible material like TPU. The glass is really good because you get absolutely flat edges with no artifact. Where with some of the other things like like a PEI bed or steel bed, you can have some waviness and some, where the plastic conforms to the bed. So if you want like absolute flat edges, it's pretty hard to beat glass.
Okay. So do you use glue to get it to stick, or do you just rely solely on the heat?
It depends on what I'm printing with. TPU will stick pretty well to the glass by itself. If you're printing like ABS, actually Elmer's or Uhu glue stick works pretty well. It gives you just enough stick to keep the part in place, but after everything cools off, it's pretty easy to pop off.
Okay, thanks.
Okay. Thanks a lot, everybody. We'll see you in January.